Hey everybody, this is Mr. McKee again with SEC 210. Today we'll be going over packet tracer 10.4. I believe it's .3. Yep. Alright, and it is, this thing is situated. Alright, using Wireshark to examine TCP and UDP captures. Alright, so we're going to be using internet connection, router, and then FTP client. Alright, let's see. Part 1 would highlight a TCP capture from an FTP session. This topology consists of the CBROPS workstation VM with internet access. Alright, so we're going to be using the mininet. Alright, that's pretty much the same as we've done before. Alright, two protocols in the TCP IP, transport layer or TCP and UDP. Both protocols support upper layer protocol communication. For example, TCP is used to provide transport layer support for the hypertext transport protocol and FTP protocols, among others. UDP provides transport layer support for the domain name system and TFTP or trivial FTP, among others. In part 1 of this lab, you will use Wireshark open source tool to capture and analyze TCP protocol header fields for FTP file transfers between the host computer and an anonymous FTP server. The terminal command line is used to connect to an anonymous FTP server and download a file. In part 2 of this lab, you will use Wireshark to capture and analyze UDP header fields for TFTP file transfers between two mininet host computers. Alright, so let's get started. Alright. So start Wireshark. So we go to terminal. This is pretty much what we've been doing a bunch. Wireshark. The end sign. Alright. So it looks like there's traffic going across Ethernet, NP, OS3, and I guess whatever that is, NE. Alright. So start the Wireshark capture for the ENPOS3. Alright, so let's go double click that. And now we're going to open another terminal window. And I'm just going to do another terminal window since that's already up there. Alright, so we're going to FTP to ftp.cdc.gov. Alright, name, anonymous. Alright, anonymous access allowed, send identity as password. Alright. So I'll use, let's just use, well, whatever. Alright, so just hit enter. No password. Alright. So notice system type Windows NT. We're at the FTP terminal. Alright. Download the readme file. So let's list. Alright. So it's taken a while. Notice we have a bunch of packets going across the network. A bunch of that stuff is coming from my cameras and my router and switches and stuff. So maybe yours is not going to be as slow as mine is. So if you get any of those errors up there, FTP server is currently down. However, you can proceed to the rest of the lab, analyzing those packets that you were able to capture and reading along for packets that you did not capture. You can also return to the lab later to see if the FTP server is back up. Alright, so I'm going to pause this video while I'm waiting for the FTP server to respond with all the files that are in that folder. Alright, it looks like the FTP server is slow, but I just put in the, instead of the listing all the files in that folder, I just did the get readme. Alright, so hopefully it downloaded it for me. Alright, after the transfer is complete, type quit. Alright, we're back to the command line. Alright, stop the packet capture. Alright, Wireshark captured many packets during the FTP session to ftp.cdc.gov to limit the amount of data for analysis. Apply the filter TCP and right here, TCP and IP ADDR equals 98.246.06. Alright. So the address 198.246.117.106 is the address for ftp.cdc.gov. At the time this lab was created, the IP address may be different, which it did work. If so, look for the first TCP packet that started the three-way handshake with that website. Alright, so it looks like 254.90. Alright, so that's going to, yeah, it looks like it works. So notice the sync, ACK, and ACK three-way handshake. Your Wireshark interface might look slightly different than the above image. Analyze TCP fields. After the TCP filter has been applied, the first three packets, right there, sync, ACK, and ACK. TCP is routinely used during a session to control datagram delivery, verify datagram arrival, and manage window size. For each data exchange between the FTP client and FTP server, a new TCP session is started. At the conclusion of the data transfer, the TCP session is closed. When the FTP session is finished, TCP performs an orderly shutdown and termination. Alright, in Wireshark, detailed TCP information is available in the packet details pane. Alright, we'll get into that, which is the middle section. Highlight the first datagram from the host computer, right there. And expand portions of the TCP datagram. And they have, let's see, they've opened the flag up. Alright. Let's see. The expanded TCP datagram appears similar to the packet detail pane as shown below. Let's see if I can get this a little bit bigger. Okay. Alright, the image above is a TCP diagram. An example of each field is provided for reference. Alright, TCP source port number belongs to the TCP session host that opened the connection. The value is normally a random value above 1023 because remember 0 to 1023 are well-known ports. Let's see if I can find it. There we go, source port right there. Alright, TCP destination port number is used to identify upper letter protocol or application on the remote site. The values in the range 0 to 1023 represent well-known ports and are associated with popular services and applications such as Telnet, FTP, and HTTP. The combination of source IP address, source port, destination IP, and destination port uniquely identifies the session to the sender and receiver. Alright, in the Wireshark capture above, the destination port is 21. Notice right there, right, which is FTP. FTP servers listed on port 21 for FTP client connections. The segment number specifies the number of the last octet in the segment. All right. The acknowledgement number specifies the next octet expected by the receiver. Right there. Let's see all zeros down there. All right, so the code bits have a special meaning in session management and in the treatment of segments. Among interesting values are ACK, sync, and fin. Like ACK, sync, fin. All right, acknowledgement of the segment receipt. Sync, synchronize, only set when the new TCP session is negotiated during TCP three-way handshake, which this is starting the three-way handshake, so that makes sense. Fin, finish, the request is to close the TCP session. The window size, notice right there, window size value, is the value of the sliding window. It determines how many octets can be sent before waiting for an acknowledgement. All right. And notice that right there's in hex. It looks like FA, F0. All right. So the urgent pointer right there is only used when an urgent flag, when the sender needs to send urgent data to the receiver. The options, let's see, options down here, urgent pointer there, options. Has only one option currently, and it is defined as a maximum TCP segment size. Right, notice maximum segment size 1460 bytes. Using the Wireshark capture for the first TCP session startup, sync bit set to 1, which that's what we have right now. Fill in the information about the TCP header. Some fields may not apply to this packet. All right, so you guys can go ahead and fill that out. In the second Wireshark filtered capture, the CDC FTP server acknowledges the request from the VM. So I'm going to click on the second one. Right, notice the second one has acknowledgement and sync. Fill out the following information regarding the sync ACK message, which is the second one. Notice sync ACK. Alright, in the final stage of the negotiation to establish communications, the VM sends an acknowledgement message to the server. Notice that only the acknowledgement bit is set to 1, so let's go ahead and click on that. Alright, notice sync's not set, but acknowledgement is set. Alright, and the sequence number is incremented to 1. Notice right there, sequence number. Okay. All right, fill out the following information regarding the ACK message. How many other TCP datagrams contain a sync bit? And I'm assuming it's referring to the other. You guys can look through there and find those. You can see a lot of sync bits in there. All right, after a TCP session is established, FTP traffic can occur between the PC and FTP server. Let's get back up here. All right, so three-way handshake, next one's an FTP. All right. The FTP client and server communicate with each other, unaware that TCP has control and management over the session. All right. When the FTP server sends a response 220 to the FTP client, the TCP session on the FTP client sends an acknowledgement to the TCP session on the server. All right, the sequence is visible in the Wireshark capture below. All right, notice response 220, Microsoft FTP service. And remember, this is we're communicating with a Windows. It says Windows NT or Microsoft NT. When the FTP session has finished, the FTP client sends a command to quit. The FTP server acknowledges the FTP termination with a response 221. At this time, the FTP server or TCP session sends a TCP datagram to the FTP client announcing the termination of the TCP session. The FTP client TCP session acknowledges receipt of the termination datagram, then sends its own TCP session termination. When the originator of the TCP termination, the FTP server, receives the duplicate termination, an ACK datagram is sent to acknowledge the termination and the TCP session is closed. This sequence is visible in the datagram and capture below. All right, so if we notice here, let's see, that's where we requested access as anonymous. Access was granted. User logged in. Response 215. Let's see if I can find a 221. All right, so that, there you go, there's 220. Let's find 221. There you go, there's 221. FTP quit response coming from the server to us saying goodbye. All right. By applying the FTP filter, the entire sequence of the FTP traffic can be examined in Wireshark. So let's do that. FTP. All right. And notice you can see all the stuff there. Password required, pass. User, well, the user couldn't log in the first time, but I tried it again. All right. The username anonymous was used to retrieve the README file. After the file transfer completed, the user ended the TCP session. Apply the TCP filter again to Wireshark to examine the termination. All right, so TCP. All right. So notice it. Password required. All right, notice. Let's see if I can find my FIN-ACK. All right, there is a FTP quit, FTP response, goodbye, FIN and ACK. Okay. All right. So we applied the filter. 4 packets are transmitted for the termination of the TCP session because TCP connection is full duplex. Each direction must terminate independently. Examine the source and destination addresses. In this example, the FTP server has no more data to send in the stream. It sends a segment in with the FIN flag set in frame 149. Now my frames will be different. PC sends an ACK acknowledgement to acknowledge the receipt of the FIN ACK. All right, FIN acknowledgement, FIN ACK acknowledgement. All right. let's see, in frame 151, the PC sends a FIN to the FTP server to terminate the TCP session. The FTP server responds with an ACK to acknowledge the FIN from the PC in frame 152. Now the TCP session is terminated between the FTP server and PC. All right. So now we're going to identify UDP header fields and operation using the Wireshark TFTP session capture. You can use Wireshark to capture a TFTP session and inspect the UDP header fields. All right, so let's shut this down for now. Quit without saving, that's fine. All right, I'm going to clear the screen. All right, so I'm going to do sudo lab support files scripts. Whoops. Scripts and CBROPS topo. Alright. CBROPS. Alright, my mininet is started. Okay. So we're going to open up H1 and H2 in xterm. H1. Whoops. Xterm H2. Alright, so there's our two hosts terminals. Alright. Create a text file in the H1 terminal prompt in the serve TFTP server. Alright, so let's look at this. Alright. So we're just going to use echo. This file contains my TFTP data. Alright, and save that to srv TFTP I underscore TFTP underscore data. Alright. Verify the file has been created with the desired data in the folder. Cat srv TFTP my TFTP. Alright, this file contains my TFTP data. Alright, so it's in there. Alright, because of the security measure for this particular TFTP server, the name of the receiving file needs to exist already. On H2, create a file named myftpdata. Alright, so we use touch my TFTP underscore data. Alright, so that started that. Well, I'm not going to even show you guys because it's empty. But if we did a list, you can see it right here. Where's that? My FTP data. All right. I'm going to clear this. All right. So capture a TFTP session in Wireshark. Start Wireshark in H1. All right. Wireshark. Alright, so that's starting. From the edit menu, choose preferences. Alright, and click the arrow to expand protocols, like such. Scroll down and select UDP. UDP is right there. Alright, click to validate the UDP checksum, if possible, and click OK. Alright, start the Wireshark capture on the H1 Ethernet 0 interface. Alright, notice it's started. Alright, so start the FTP session from H2 to the TFTP server on H1 and get the file. Alright, so TFTP 10.0.0.11. get FTP data. Alright, stop the Wireshark capture. Actually, I don't know if I got enough packets. I got 2. Yeah, I should have TFT protocol. TFTP. Alright, let's just do TFTP. TFTP. Alright, there we go. Alright, use the 3 TFTP packets to fill in the table and answer the questions in the rest of the lab. Alright, so I'm going to actually clear this. Do that. Alright, so now I'm going to stop it. Alright, TFTP. DataNet. It's weird if I'm getting that. My TFTP data. Let's look check here. Server. Alright, I had to back up some. I missed one line. I didn't start my TFTP server. That made sense. Alright, so I'm right here. Starting at step 1. Alright, start up Mininet. Alright, I'm going to start up my sudo. So I'm actually right here. Xterm, H1, H2. Alright, that starts my 2 terminals. Now, what I didn't do that time was, let's go home, analyst, analyst. Oh yeah, I'm messing this thing up. Alright, on H1, there we go. Alright, so home, analyst, lab, support files, scripts, start, underscore TFTP. Let's see if it populated that. Alright, now TFTP started. Now let's create a file. Alright, so H1. Alright, so let's see. Cat SRV T. Sorry, but that was super loud. Alright, TFTP my underscore TFTP underscore data. Alright. Oh, I'm sorry. You know what? H1. Create a file on H1. prompt server TFTP. Alright. Code this file contains my TFTP data. Alright, on and serve TFTP my no space left on device. Alright, well let's go cd srv TFTP my TFTP. Alright, now I took that file out because I created it earlier. I just want to redo it. Alright. Echo, this file contains my FTP data. srv TFTP. Alright, so I'm going to try this one more time. I reloaded my virtual machine because it was out of memory. It's very strange. Alright, so I'm going to start at part 2 once more. Alright, so let's do sudo support files, scripts, and CBROPS. Topo. Alright, cyber. Alright, there's my mininet. Alright, let's start up xterm with H1 and H2. Alright, there's those two. Alright, so in H1, let's do home, analyst, lab, support files, scripts, and start underscore TFTP. Can't see it. TFTP dot shell. Okay. Alright, so that should be running. Alright, create a file at the H1 terminal. Alright, this file contains my TFTP data. Alright, srv TFTP my underscore TFTP underscore data. Alright, so let's do cat srv TFTP my TFTP data. Alright, there we go. That looks good. Alright. So, and then because of the security measure for this particular TFTP server, the name of the receiving file needs to exist already on H2. Let's do touch my underscore TFTP underscore data. Alright, so I got that. Now start Wireshark on H1. Alright, so there's Wireshark. From the edit, go to choose preferences. Whoops, go back. File, edit, preferences. Alright, expand protocols, and then UDP. Alright, all the way down, UDP. Like such, and validate UDP checksum. Okay, I got to see some traffic on there. Right, start a wire capture on interface H1 Ethernet 0. Alright, there we go. Alright, start a TFTP session from H2. Alright, TFTP 10.0.0.11. Option C, get my. All right, let's see if it works now. I'm going to wait to make sure it goes through. Transfer timed out. What in the world? All right, let's stop this. Let's look at TFTP. Very strange. Oh, duh. Let's put a valid IP address in there. Actually, let's stop this and go here, like so. Now let's go. All right, there we go, finally. All right, TFTP data block acknowledgement. All right, now we'll stop that. Finally, it worked. All right, and we're sorting by TFTP. All right, detailed UDP information is available in the Wireshark packet data details pane. All right, user datagram. Make this a little bit bigger. So, all right. So notice source port and destination port. All right. TFTP is right down here. All right. Notice read request and source file my TFTP data. All right, use the Wireshark capture the first UDP datagram, fill in the information about the UDP header, all right, which is right there. All right. So how does UDP verify data integrity, datagram integrity? All right. Might be able to look on there. All right, examine the first frame returned from the TFTP server, which is right here, data packet. What's weird, it got checksum was incorrect, should be maybe caused by UDP checksum offload. Which is strange because it's still got the payload right there. This file contains my TFTP data. All right, fill out the information about the UDP header. All right, so let's see. All right, there's the second header. All right, so just fill it out. Notice the return UDP datagram has a different UDP source port. All right, but this source port is used for the remainder of the TFTP transfer. Because there's no reliable connection, only the original source port used to begin the TFTP session is used to maintain the TFTP transfer. Also, notice that the UDP checksum is incorrect. All right, as it shows, this is most likely caused by UDP checksum overload. You can learn more about why this happens by searching UDP checksum offload. All right. So now that we've seen that, I'm going to go to quit mininet. All right, and then sudo and right, CBROPS. Okay, the lab provided the opportunity to analyze TCP and UDP protocol operations from captured FTP and TFTP sessions. How does TCP manage communication differently than UDP? I'll let you guys answer that. You can do a little web search if you don't know for sure. All right, and that's it. Thanks for watching. Yeah, what I did though, I downloaded, if you guys have the same problem where it says you're out of memory on your H1 or H2, I actually reinstalled the virtual machine. And also make sure when you're running your VBox, make sure you have a good snapshot. All right, like a fresh snapshot. Do that the first thing when you set up your virtual machine again. And that's it. Thanks for watching.